All right, so here's another categorical versus quantitative variable example. So again, the question asked, the way we ask our question can determine if the resulting answer or data or variable collected is categorical or quantitative. So in this example, a recent newspaper article reported on Americans' eating habits. The article reported that only about 1/3 of American adults ate 2 or more servings of fruit per day, and only 26% ate 3 or more servings of vegetables per day. Californians ate the most fruit, while Tennesseans ate the most vegetables. So the phrase 26% ate 3 or more servings of vegetables per day refers to what kind of variable and why? You can pause here and try to answer the question on your own. So this one's kind of a trick question. The variable could be either quantitative or categorical, depending on whether the subjects were asked how many servings of vegetables per day they ate, or whether they were asked if they ate 3 or more servings of vegetable per day, respectively. Right, so this is something we weren't given, right? But the way the question was asked to the who, right, or the sample here affects our answer, right? So they've displayed it in this way. To me, that seems it's more of a categorical, right? They've reported on adults who eat 2 or more servings of fruit per day. That seems like a category. And then another group who ate 3 or more servings per day, right? But notice too that those groups could overlap, right? Where our categorical variables should never overlap. If I eat 3 servings of vegetable a day, and if I'm a part of this sample, well, then I fall into both of these categories, right? I fall into the 2 or more servings of fruit per day, and I also fall into the 3 or more servings, right? Because 3 is more than 2, and 3 is obviously equal to 3, so I'm falling into both categories. So again, it depends on how the researcher asked this question, right? If they asked how many servings of vegetables do you eat per day? Well, I could eat 0 servings, right? I could eat 0.25 servings, exactly 1/4, or I could eat 1/2 of a serving. I could eat 2, 3, 4, 5, 5.5, right? And so on. But if they asked it in a different way, if they asked, do you eat 3 or more servings of vegetables per day? Or do you eat less than 3 servings of vegetables per day, right? Those are 2 distinct categories, and that would make this a categorical variable. You either eat less than 3 servings of vegetables per day, or you eat 3 or more servings per day. Kind of tricky. So the why, where, when, and how do matter. Um, we can ask ourselves, is our data useful or relevant? If for the why, if Procter & Gamble, who's a drug manufacturer, conducts its own study to determine the effectiveness of its own pain reliever. Obviously, as Procter & Gamble is making this pain reliever, right, they're going to be a little biased towards it, right? They've got incentive, they want it to do well and to sell. So bias can creep in, right, and affect their study and the data they collect. An example of where is if we collect voter opinion in Vermont to predict all of the US. Well, we know the US, right, has many different regions, many different states, obviously. and voter opinions vary widely, right, from state to state. So if we just use one state, such as Vermont, one small region of the United States, to try to predict all of the United States' opinions, we're probably not going to get very good answers. An example for win is we use data gathered before 2000 to predict current cell phone usage in 2024. This one's pretty silly, right? Because very few people had cell phones before the year 2000. There were those things that were as big as your face, right? Cell phones before 2000 didn't do nearly what cell phones can do now. So if we were to look at data on cell phone usage before 2000, it would not reflect cell phone usage today. And finally, how, if there's a researcher who's dressed as a police officer asking teens if they have used illegal drugs, the teen is probably not likely to confess that or respond truthfully, right, to a police officer asking them if they have broken the law. So this stuff does matter, right? In order to collect useful and relevant data, we want to try to follow good practices when it comes to the why, where, when, and how. So what can go wrong? Don't label a variable as categorical or quantitative without thinking about the question you want it to answer and how it is measured. Some data are reported as numbers, but they are not quantitative variables. Think about jersey numbers, right? You can't have a 0.5 or a 1.5 jersey number, right? Those can only be 0 through maybe it's 99, right? But those are 99 distinct categories, right, for jersey numbers. You can't have a jersey number that's 100 or 101 or 1000, right? There's a finite number of categories or of jersey numbers out there. ISBN numbers, social security numbers, right? We each have our own unique social security number. But those things are unique to us. There's not a ... 0.5 social security number 0.1, right? It's 1-2-3. It's a unique number. Or zip codes, right? Zip codes are made of numbers, but they're not truly, a number in the sense of you can have a 32804.1 zip code, right? It's not 3208.1. The zip code is more of a unique category. It doesn't make sense to take the average, right, of all zip codes. They're not real numbers, so to speak. They also aren't measured with units. This is a good giveaway with something is categorical, if it doesn't have units. And always be skeptical. Don't take data for granted.